Hello dear students, welcome back to SEMA's grade 10 classes. Dear students, today you are going to learn one important chapter, that is electricity in physics. In electricity, what are the concepts you have to learn in this chapter means electric current and electric potential and potential difference, then Ohm's law and their numericals, then factors affecting the resistance, then resistance in series, resistance in parallel, and electric effects of electric current, heating effects of electric current. These are the learning points you have to learn in this chapter. First of all, dear students, you have to see the meaning of electric current. Let's see now what is meant by electric current. Dear students, what are the conductors? What are the conductors? The material which allow the electricity, that materials are called conductors. And the material which do not allow the electricity, that are called insulator. What's it? Insulator. What are the examples for conductors? Copper, aluminium, iron. These are the examples for conductor. Copper will allow the electricity. Then aluminium also allow the electricity. Then what are the insulators? Plastic, wood. These are the some examples for insulator. Dear students, why the only conductors will allow the electricity? Why? What is the reason? Why? Due to presence of free electrons. Due to presence of free electrons. So what this means? What is meant by free electrons? Where will be present? Let's see now. Dear students, which metal is used in the electric wires? Which metal is used commonly in the electric wires? Copper. Copper is symbol is copper. And what is the atomic number of copper? 29. Now atomic structure, I'll write C, Cu. Here will be the 1, then here will be the 8 electrons. Then the next shell, electrons will be present in the next shell. Then the outermost shell, 1 electron will be present. 1 electron will be present. This is the electron. Dear student, from first shell 2 electrons, the next shell 8 electrons, then third shell 18 electrons, the last shell has the only 1 electron. This we call free electron. These free electrons will be present in only some metals. That only will allow the electricity. For example, see here one atom. This is the nucleus. Here will be present that electron. When we apply the force, when we apply the force for this atom, see, this electron will easily come out from that atom. Is it right? See, my dear student, here also electrons will be present. This shell also electrons will be present. This shell also electrons will be present. Which electron can we take easily from this atom? Which electron? Outermost shell electron. Outermost shell electron. My dear students, the electron present in the outermost layer of the atom, that electron we call valency. That electron we call valency. See, when we apply the force or energy for this atom, this electron will be come out from this atom to the next atom. Again, when we apply the force for this atom also, this electron will be starts moving from another atom. Like this, when we apply the force or energy for any one atom, starts the electrons moving from one atom to the another atom to the next atom. Like this, electrons will be flow from one atom to another atom to the next atom. Understand? Flow of charges in a unit time. Flow of charges in a unit time we call electric current. That flow of charges in a unit time, that we can also call as a rate of flow of electric charges. Rate of flow of charges is called electric current. I write definition here. Rate of flow of charges is called electric current. Rate of flow of charges is called electric current. Electric current. This is the definition of electric current. Now let's see what is the formula of electric current. Dear student, electric current is denoted by the symbol or symbolic representation I. I we call electric current. Rate of flow of, it means before I told flow of charges per unit time. Flow of charges per unit time. Charge can be represented by Q, and rate of flow of charges can be also called as a flow of charges per unit time. Flow of charges per unit time. Unit time we call time T. Understand? See, I is equal to Q by T. I refers to current. Q refers to what? Charge. Then T refers to time. I is equal to Q by T. This is the formula for electric current. Let's see now what is the SI unit of electric current. SI unit of electric current. SI unit of electric current. I is equal to Q by T. It's a electric current formula. Is it right? I SI unit is ampere and Q SI unit is charge. Charge divided by time. Second. Its SI unit is second. Q nothing but charge. Charge SI unit is coulomb. Coulomb. Q coulomb per second. Coulomb per second. Q nothing but charge. Charge SI unit is coulomb and time SI unit is second and current SI unit is ampere. Understand? A is equal to coulomb per second. Coulomb per second. We can indicate this one in symbolic representation C by S. C by S. C nothing but coulomb. S nothing but second. Understand? The SI unit of electric current is what? Coulomb per second. Coulomb per second is the SI unit of electric current. Understand? Why we call ampere? The SI unit of electric current is coulomb per second, not a ampere. If you written ampere also, half mark you will get. Why? Nothing but electric current is discovered the scientist who Andre Ampere. Andre Ampere. He was one of the scientists who discovered the electric current. So that his name only kept for this SI unit. SI unit is ampere. If you written ampere, only half mark will you get. So you should write coulomb per second is the SI unit of electric current. Understand? Now, how will you define 1 ampere? Define 1 ampere. Can ask in examination. Define 1 ampere. Before going to define this, you have to write first formula of electric current. Formula of electric current. I is equal to what? Formula Q by T. It is the formula of electric current. Then this formula you have to write it in the terms of SI unit. This formula you have to write it in terms of SI unit. SI unit is ampere is equal to Q SI unit is coulomb and T SI unit is second. Understand? Then you have to write 1. You have to write numerical 1 in front of these SI units. Understand? By seeing this now you can make it a sentence for 1 ampere. 1 ampere is said to be 1 coulomb of charge is flowing in the circuit at a 1 second. This is called 1 ampere. I'll repeat once again. 1 ampere is said to be 1 coulomb of charge. 1 coulomb of charge is flows through the circuit at 1 second is called 1 ampere. 1 ampere is said to be 1 coulomb of charge is flows through the circuit at 1 second. At 1 second is called 1 ampere. Understand? 1 ampere is said to be 1 coulomb of charge is flows through the circuit or flows through the conductor at a 1 second, that we can call 1 ampere. Understand? Dear students, you know now definition of electric current and formula of electric current, SI unit of electric current, then how to define 1 ampere and which device is used to measure the electric current. Which device? Ammeter. What's a ammeter? Ammeter is a device is used to measure the electric current in the circuit. Dear students, now let's see some numerical problems.